The electric dipole moment of an electron and a proton is 5 nanometer apart. Here they given this is electron and this one is proton. Okay, the electron is having negative charge and proton it is having positive charge, and it is separated by some distance 5 nanometer. Okay, they are asking the electric dipole moment. The formula for electric dipole moment is charge. This is the charge of electron. This is charge of electron and Q is the charge of the photon. So Q into the distance separated here. So we know that charge of electron and proton is 1.6 into 10 power minus 19 coulomb. Okay, so here we can write the electric dipole moment Q is 1.6 into 10 power minus 19 into the distance, we took the distance as 5 nanometer. So 5 into nano means 10 power minus 9 meter. This is in coulomb. Okay. Now if you multiply this one, what is this? 1.6 into 5 into this 10 power minus 19, and here we are having 10 power minus 9 minus 28, and here we are having coulomb meter. So this is coulomb meter. If you multiply these two, 1.6 and 5, you will get the answer 8 into 10 power minus 28 coulomb meter. The correct option is 8 into 10 power minus 28 coulomb meter. Liquid oxygen at 50 Kelvin is heated 323 Kelvin at constant atmospheric pressure 1. The rate of heating is constant here. From the following graph, which represent the variation of temperature with time. Now, this is a vessel which contains liquid oxygen. Now, I am going to heat the liquid oxygen now at 50 Kelvin to 323 Kelvin. Now, if I heat, we want to plot a graph between time versus temperature. So, if I am heating the oxygen, liquid oxygen, the temperature increases up to some point. So, first step, the temperature increases when heating. Okay. So, second step, there is a conversion of liquid to the gaseous state occurs here at the second step. So, liquid is changes from liquid oxygen is changes from gaseous state. That temperature is known as boiling point. The particular temperature is known as boiling point. So, we are saying this temperature as boiling point. Now, at boiling point, the liquid as well as gaseous states are in equilibrium position. Equilibrium position is nothing but that is a steady state. So, this becomes as an equilibrium now. Equilibrium state. That is nothing but steady state. So, at this state, when we are applying the heat also, the temperature won't increase. So, it becomes as a constant. The temperature is constant for particular time, and then it increases here. So, this is the graph we are getting. First, the temperature increases and it becomes as an equilibrium state. It is constant here, and then when you are applying the heat, it again increases. So, this is the correct option. A stone is thrown with the initial speed of 5 meter per second from a bridge in vertically upward direction. It falls down in water after 2 seconds. We need to find the height of the bridge now. So this is the bridge I am taking. A person is here. He is throwing a stone from the bridge to the surface of the water level. This is the surface of the water level. They given here the second it reaches is 2 seconds. Within 2 seconds the stone reaches the surface of the water level. And here the initial speed, initial velocity we are taking as u is equal to 5 meter per second. So what is the given value here? Given initial speed, initial velocity u is equal to 5 meter per second. It is, we are throwing the stone in the upward direction. In the upward direction means it is the sign, the direction is here negative. Downward direction means due to the force of attraction, that is positive. Downward means positive and upward direction means we need to put here negative sign. So 5 meter per second. We know the acceleration due to gravity g is equal to 9.8 meter per second. This is a constant value. And find the solution according to the kinematic equation. Okay, second equation, height h is equal to ut plus half at square. This is the formula you studied in the kinematic equation number 2. Okay, equation 2. Now they given we need to find the height of the bridge. What is the height of the bridge here? U is the initial velocity. We taken the initial velocity as minus 5. T is equal to 2 seconds. So into 2 plus half. Acceleration due to gravity is 9.8. T square. So T is 2 into 2. So 2 get cancelled here. Now minus 10 plus 9.8 into 2, that is 9.8 into 2 is 19.6. So 10 minus 10 plus 19.6 is 9.6 meter. So the height of the bridge is 9.6 meter. So the option is here number 2, 9.6 meter.
Match the following. The first one is riboflavin, which is nothing but vitamin B2. This deficiency which increase the burning sensation on the skin. Then second one is pyridoxine. This is nothing but vitamin B6. The deficiency of pyridoxine leads to convulsions. Then third one is thiamine. Thiamine is a vitamin B1 compound. This B1, the deficiency of thiamine which leads to the loss of appetite. Then fourth one is vitamin K. The deficiency of vitamin K leads to increased blood clotting time. So the correct answer is option 3. 4, 2, 1, 3. Calculate the number of sigma and pi bonds are present in the following compounds. The compound is 2,9-dimethyl 3,6 decadiene. Deca, which means 10 carbon atoms. So we have to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon atoms. And 2,9 dimethyl, 2 and 9 position having methyl group. So here 1, 2, this position is having 1 methyl group, and 9th position also having 1 methyl group. Then 3 and 6 position, there is a dienes are present. Here third position, here there is a diene, and 6th position also having a diene. Then fill the remaining bonds with hydrogen. 1, 2, 3. Carbon has a 4 valency, so we have to fill 4. Here the number of sigma bonds are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So the number of sigma bonds are 33 bonds are present. Then number of pi bonds, here 1 pi bond is present, and this portion also 1 pi bond is present. So number of pi bonds are 2. Here the option 2 is correct. 33 sigma bond and 2 pi bonds. Depict the galvanic cell in which the given reaction takes place. Here the anode is copper, then copper 2 plus is a concentration, then salt bridge followed by Ag plus Ag. This is the galvanic representation of the reaction. So the answer is option 1.
Select the correct pattern of arrangement of reproductive structures of gymnosperms. We know that gymnosperms are naked seeded plant. To know about the arrangement, the proper sequence of the reproductive pattern, we should know the structure of the reproductive organs the gymnosperms possess, isn't it? They are heterophilous, so they have both male and female reproductive parts. From the image we can see that gymnosperms possess spores which are enclosed in sporangium, and these sporangium are covered by leaf-like structures which are called as sporophyll. So the correct sequence will be first spores, then sporangium, sporophylls and strobilae. So the correct option is option 4. Which of the following algae produces carrageen? Blue-green algae, brown and red algae. What is carrageen? Carrageen are hydrocolloids, are capable of holding water. Algene and carrageen are two hydrocolloids which is produced by brown and red algae. So in the question they have asked about carrageen. So the correct answer is red algae, which is option 4. Match the following: natural auxin, synthetic auxin, Beckham disease of rice and natural cytokinin. Natural auxins are indole acetic acid, indole butyric acid, indole propionic acid, and few examples of synthetic auxins are naphthalene acetic acid and dichlorophenoxy acetic acid. And when a rice is affected with Beckham disease, gibberellic acid is used to treat. And coming to natural cytokinins, two examples are zeatin and dihydrozeatin. So the answer would be, coming to natural auxin, IAA. IAA is a natural auxin, and synthetic auxin is naphthalene acetic acid, and I said GA3. Gibberellic acid is used to treat Beckham disease, and the natural cytokinin is zeatin. 1C, so 2A, and the correct option would be the first one.
The type of chromosome given in the diagram is, the options are metacentric, submetacentric, acrocentric and telocentric. So you can see the diagram, they have asked about the type of chromosome. The answer is 3, acrocentric, because we all know chromosomes are classified into 4 different types depending upon the position of the centromere. Okay, so this is centromere. Depending upon the position of the centromere, they are classified into telocentric, acrocentric, submetacentric and metacentric. In metacentric, the centromere is placed in the middle. So, they have 2 equal arms. In submetacentric, the centromere is placed a little away from the middle. In acrocentric, the centromere is placed close to the terminal region. So, and in telocentric, it is present in the terminal region. In acrocentric, it is close to the terminal region. So, as we all saw in the diagram, we saw acrocentric chromosome. So, the option 3 is correct. The steroid hormone among the following is, the options are insulin, epinephrine, luteinizing hormone and cortisol. So, we have to find out which is the steroid hormone. The answer is option 4, cortisol. So, we can see the hormones are classified based upon the chemical composition into peptide hormones, steroid hormones, amino acid hormones and fatty acid hormones. So, the cortisol comes under steroid hormones. The hypothalamic and pituitary hormones and insulin, parathormone and calcitonin. So, all these hormones comes under protein or peptide hormones. Majority of the hormones are protein or peptide hormones. The cortisol, aldosterone from adrenal cortex, they are steroid hormones, and the sex hormones estrogen, androgens and progesterone along with the vitamin D. These hormones, they are also steroid hormones, and adrenaline and noradrenaline from adrenal medulla, they are amino acid hormones, because we all know they are also known as catecholamines. So, amines, they are amino acid hormones, along with that thyroid hormone and melatonin. They are also amino acid hormones, and prostaglandins, thromboxanes and prostacyclin come under fatty acids. So, here they have asked about which of the hormones is steroid hormone, and the answer is option 4, cortisol. The digestive system of mollusks contain a rasping organ called. So, the options are radula, hemocoel, statocyst and proboscis. So, the correct answer is radula. The mollusks, so the mollusca contain a rasping organ called as radula. Here we can see, so in this picture, this is the picture of snail. So, snail. This is the image of octopus. You can see in the mouth there is a teeth belt or tongue like structure which is called as radula. This radula is used for feeding. Okay. Here in octopus also we can see the teeth belt like structure called radula. So, radula is the correct answer. Coming to other options, hemocoel. Hemocoel is the body cavity which has circulatory fluid. So, the body cavity of invertebrates, okay, not vertebrates, invertebrates, which contain circulatory fluid is called as hemocoel. Statocyst. Statocyst is the organ of balance in invertebrates. Stato, okay, so organ of balance in invertebrates. And last, proboscis. This is found in hemichordata like balanoglossus, where they will be present in the anterior part. Okay, they are also used for feeding as well as locomotion. So, proboscis present in the anterior part of the hemichordata. So, in this question the answer will be radula, which is the feeding organ for mollusks. The option 1 is correct answer.